Okay, good day everybody. This is the T3 Airport Expansion Project, and we're talking about the building management system. The building management system, i.e. the BMS, have been supplied, tested, commissioned, and is active by Honeywell. The BMS in the bus gate building, it's used for monitoring and control specific equipment and items that are located in this building. It's integrated with the T3 airport. Although we have one server that is located here, this one is directly reporting to the main T3 terminal, and all the commands and all the monitoring can be done from Terminal 3 through this integration. Currently, we set up our local BMS server right here in the UPS room. It's one of those clean rooms with the AC working. Everything is there. We've got one main computer there that we're going to be able to monitor all the items of this building. And because it's on a LAN network, it's going to be connected to the main Terminal 3 through a specific IP address and can be monitored and controlled from the Terminal 3. So we've got 5 DDC panels for the BMS in our system. We've got panel number 1 for the mechanical room. We've got panel number 2 for roof area A, which controls 2 RTU units, RTU2, RTU3. We've got one panel located in area D. It controls the RTU1 and RTU4. We've got one panel in the electrical room 105 and another panel in the electrical room 134. All panels are connected to a LAN network, and whichever computer plugs into the LAN network, if it has the specific credentials and the specified IP address, they can access the full network. Or if you plug your specific computer to every single DDC panel through the proper connection, you can control and monitor this specific panel and its outgoings and their sensors. Okay, so I took a small screenshot of the DDC panels. We've got 1, 2, and it kind of shows the interconnection, and each DDC panel, what is it affecting or what is it controlling and what is it monitoring. The specifics are there in the operation manual. It's going to be a hassle going into it. And we've got the BMS station that is located in the UPS room right now, and it's directly integrated and it's connected to the main existing Terminal 3. Terminal 3 has been done by Honeywell, so the integration process is very simple. For the graphics, we ask them to follow all their previous design and all their previous the graphics as they did for Terminal 3 to do it for this bus gate building. So the integration process will be very simple. Okay, components. Our BMS is handling the air handling units. It's controlling the fans. Here we're showing that which items are actually controlled and which items are monitored. If we're mentioning that it's controlled, that means you can go through your graphical representation, you can click on the unit, you can activate this damper, you can increase the voltage of this fan, you can decrease the voltage of that fan. All of this is integrated. We have a lot of machines that we are just monitoring. Through BMS, we have a gas detection, a gas leak detection for the split units that are located for the communication rooms. We have all the DBs, all the SMDBs, they have a monitoring. Because the air handling units, energy recovery leads, variable air volumes. The system for the air handling is a high pressure variable air volume terminals we have in every single branch. Basically, the RTU will be supplying specific air, and through the BMS, you can control each zone, how much you want the temperature there. By such, you're affecting the VAV. The VAV will send signals to the RTU unit through the BMS to decrease the fan speed, which in turn decreases the temperature in our system. We've got the exhaust fans, the smoke fans, the chilled water pumps monitored. You can increase, you can decrease. We've got the water pumps, collection tanks, the booster pumps. All the DBs is a monitor, whether we have a fault. We've got the elevators. We've got the lifts also integrated as a monitoring to see where is the location, is it active, is it operational, is it under maintenance, or all of that. The BMS, it monitors through sensors. These sensors has a very wide range. I'm mentioning here a couple of the simple ones, or the ones that were mostly used. The differential pressure switch, which is installed on the last main branch of the chilled water network. It will detect the pressure difference between the supply and the return line and report back to the BMS, which in turn will control the chilled water pump, whether to decrease the pressure or increase the pressure based on this pressure. Linear valve actuator, which is located on the FCUs and RTUs. Once you set up the temperature that you require, either through the thermostat or through your BMS, the linear actuators will actually adjust themselves to supply whatever required volume of chilled water to the RTU and to make it either colder or hotter based on the specific temperature. We've got the damper actuators. These are monitored and controlled by the BMS, whether you want 60% fresh air, whether you want 20% fresh air, whether you want to close completely the fresh air and use your return based on the condition, external or the user-specific ones. We've got digital wall modules, which is located across the areas everywhere, where the user, if by the BMS personnel, they give this chance or they give this operational authority to the people in the space to actually arrange this temperature or adjust the temperature, they will be active. Otherwise, the BMS will have the control. So if the BMS is set at 22, no user can put it at 21 or 20. And now we are in the phase of discussing this with the designer regarding providing plastic boxes for these modules so that not everybody can come and start playing with it. We've got small linear valves. These are installed on the fan coil units. In the bridge area, we have 3, and we have in the trash room, and we have in the UPS room. We've got BTU meters. We have 6 BTU meters in total. Each BTU meter has 2 temperature sensors on the supply, on the return, and we've got 1 flow meter. All of these are integrated with the BTU. Every single point, you can manage it and you can monitor it from the BMS graphics. You just click on this BTU meter, you go check the flow at this particular branch, check the temperature that is on the return and on the supply. 6, there are 4 RTUs, and there are 2 main branches that are going, one to the provision to the Etihad Plaza, and one on the main branch in the pump room. 6 in total. So this is kind of a schematic for the RTU unit. So we've got a fan, we've got CO, we've got pressure sensors, we've got temperature sensors, we've got temperature sensors on the chilled water supply return, we've got temperature sensors on the supply duct, we've got temperature sensor on the fresh air duct, we've got temperature sensor on the return duct. Same goes with the pressure. Also, every section of the RTU has a differential pressure sensor to measure the sensor, to sense the pressure difference between the 2 sections. This is primarily for the filters. So across your 2-inch filter, which is washable, which you can remove and you can change it, you've got a pressure sensor which show on the BMS whether it needs cleaning, whether it needs removal. And we've got one across the back filter, which is the major one. It will show the pressure difference, and accordingly you will know whether you need to replace it, whether you need to take it out, or whether it is still very suitable for operation. Yeah, this is one of the examples. I just took a screenshot. But we have, yes, we have 2 fans in every RTU. We've got the supply fan, the return fan. And this is all you can measure. The RTU, you can completely monitor it and control it from the BMS. We've got actuators on the fresh air duct. We've got actuators on the exhaust duct. We've got VFD for the supply fan and for the return fan, which is also monitored and controlled by the BMS. And we've got all the pressure sensor, we've got all the actuators. Let's talk about a little bit about the troubleshooting. So let's see the DDC panel is not seen by the BMS. So we're sitting in terminal 3 and we cannot access, let's say, these 2 RTUs. It's giving us an error report. That could be probably for the DDC panel transformer that we need to go and check. The whole panel is 24 volts energized, and if there was a power surge or unconstant power, this transformer, there are about 3 or 4 in every single. Maybe one of them got damaged, we need to take it out, replace it. Let's say we get an error on the specific sensor. We're trying to access the RTU, let's say fresh air damper. We're clicking on it, nothing is happening. We need to go back to the RTU and we need to check this sensor or this damper or this actuator to actually know what's the problem and replace it accordingly. To maintain, the room obviously has to be clean. You've got a computer sitting there. You don't want dust to go inside. You don't want it to shut down. All your DDC panels are located in closed rooms, except the 2 that are locating outside. These outside panels are IP65. They're fully sealed, waterproof. So the only issue is that once you're opening, just to check it out, to make sure that you close the DDC panel, you close the cover properly, you seal it properly, and not leave it open for dust or anything to go inside. Visual and I guess, yeah. Any questions regarding BMS?
So this SMDBs, DBs,
All monitored by the BMS. Yes, yes. And for the SMDBs, no, there is no control. You cannot switch on the breaker with BMS, right? So only control. It will show you that this breaker is tripped, or yes, it will give you the alarm, or this SMDB is not active, or that is not active.
Our RTU is all have connected to BMS, right?
Yes.
There is in the supply and the return damper, supply and the return for the RTU, there is damper or not?
For the supply?
For the supply, there is supply side of it.
Yes. No.
Damper.
You will not be able to, because the fan is actually controlled, so you don't need a damper on the supply, right?
There is no. In our RTU, there is no.
No,
damper.
no. VFD is controlling the motor, so it's controlling how much. The damper inside the RTU is fixed on the middle section between the return air and the supply air. Let's say you want 60% fresh air continuously, so this damper will be closed accordingly through BMS to actually give only 40% of return duct to go into your space.
What I'm trying to say, this is our RTU, okay?
Yes.
Here we are getting the duct for the supply.
Yes.
Between the RTU and the duct, there is damper.
There will be no damper on the supply. No, there are no dampers now. No. For the fresh air, yes. 2 fresh air on every single RTU, on the 4 RTUs, both are connected to the BMS. So you can control how much fresh air you're intaking. Fire dampers are installed on the communication rooms, and fire smoke dampers are installed on the communication rooms and the UPS room, and this is monitored by the BMS. Anything else? Perfect. Thank you very much.